Now that we've looked at the basics of mechanical weeding, let's look at some more of the detail. This will include some of the factors that will either enhance or hinder the effectiveness of mechanical weeding. We will introduce some of the key factors to ensure the best results. The fertility of weeds following mechanical cultivation is strongly linked to the size of the weed at the time of weeding, and so therefore the timeliness of this is absolutely critical. In the UK, mechanical weeding is rarely possible in the autumn due to moist soils, particularly where delayed sowing has been used, and as only the smallest weeds are controlled by harrowing, it is rarely an option as the weeds are too big in autumn sown crops by the time soils are suitable. This is why in-row cultivation is a more preferable tool in these winter cereals for the UK. Harrowing can have some uses in the spring crops, where the weed size is much smaller, but the soil conditions are appropriate enough to get the harrow to work really well. In-row cultivation is capable of being effective on a much larger weed due to the better cutting action derived from the hoe blade. A lot of the focus for this technology has previously been on broadleaf weeds, where effectiveness can be anywhere between 63 and 79% for a single pass. For annual grass weeds, the control from a single pass appears to be much lower, somewhere around 30 to 40%. However, this may be partially in part to conditions being less favourable when targeting blackgrass in the UK. Recent work in the UK demonstrates that using inter-row cultivation provides a useful level of top-up control, approximately 20%, but this is only where a robust herbicide has been used previously. The graph on the screen shows a really nice progression from working from an untreated crop to using cultivations on their own, to using herbicides alone, and then finally the furthest bar on the right hand side showing a truly integrated approach, giving us the best level of control. Row width is often really important when we're considering about using inter-row hoe, and whilst the row width doesn't usually affect the ability to hoe, especially with modern guidance systems that can help to avoid crop damage, using wider rows has historically been preferable, as you're able to hoe a greater proportion of the field and therefore a greater potential of weed control, and able to go hoeing in a wider range of conditions. However, any reduction in weed control in narrow rows is compensated for by greater crop competition. In wider rows there is less interspecies competition, so individual weeds that may be left can become stronger and seed return levels can be equal. This was the case in some work from 2021 in blackgrass, where despite a lower number of plants in the wide rows, this weed species has compensated in the absence of interspecific competition to give around about the same number of blackgrass heads per metre square. Other work seems to indicate that cultivations in narrow rows was better able to control intra-row weed biomass due to improved burial of the weeds close to the row, although this does obviously depend on the setup of the inter-row hoe. One of the other things to consider when using wider rows is whether the penalty of the yield is going to be significant. Often quoted above 30 centimetres, these wider rows may be prone to yield penalties, as plants can't take advantage of intercepting maximum solar radiation or ability to scavenge nutrients. Growers should be mindful of this, however our evidence suggests that in the presence of some weeds, and widths of over 30 centimetres don't result in these yield penalties. This is a really important one, and the soil conditions prior to, during, and following mechanical weeding can strongly influence its overall effectiveness. Starting right at the beginning of the season, the preparation of the land pre-sowing is really important. A surface that is as level as possible ensures a consistent working depth for the implement, so lots of care must be taken at this timing to really consider the uses later in the season. Moisture content of the soil is critical for the effectiveness of mechanical weeding, although it is more critical for time weeding, where excessive moisture prevents a suitable burying of weeds. Leaving moist soil around the root network of more developed weeds can enable them to reroot and continue to grow. As in the UK, mechanical weeding is carried out in the spring once the crop and weeds have established well and soils are drying out in the cultivation zone. It's really important to look at the weather conditions following cultivation, as these will also help to dry out weeds and ensure their fertility following cultivation. The final part is the cost of mechanical cultivation. And when you compare this to the application of herbicides, it does appear to be a very cheap operation. This is mainly due to the cost of the herbicide component, as captured in the graph as a variable cost. However, of course, this graph shows using only a herbicide versus only an inter-row cultivation approach, and therefore it doesn't actually take into account the crop yield and therefore the effect of poorer weed control as a result of mechanical-only methods. However, when used in conjunction with herbicides, then the additional weed control is able to enhance yield and generally bring a better return on weed control.